Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 7.1, Problem 7. This is Section 7.1, Problem number 7. It says the amount of time that Lazy Larry is late is uniformly distributed between 0 and 120 minutes. Find the height of the rectangle in the graph and use the graph to find the probability that Larry is more than 30 minutes late, less than 75 minutes late, and between 30 and 90 minutes late. So first we have to find the height of the rectangle before we can even try parts A, B, and C. So the rectangle has to have a total area of 1. That's the key to finding the height. So the base goes from 0 to 120. That's a base of 120. It's not always the endpoint. It's the endpoint when you start at 0. But you want the length of the base, so it is 120. So 120 times some number multiplies out to be 1. Well, it has to be 1 over 120. That'll multiply to 1. 120 base times 1 over 120 height gives you a total area of 1. So every uniformly distributed problem has a rectangle for a graph, and every rectangle has to have a total area of 1 for uniform probability. Whether it's low and long or narrow and high, they all have to multiply out to be 1. So now that we have the height is 120, let's do ABC. A, what's the probability that he's more than 30 minutes late? So it's 30 minutes late, so more than 30 minutes late. So we would have a base from 30 to 120. The base would be 90. So you figure, what's the probability of being in this area, more than 30 minutes late? So the area is going to be base times height. So the base we said is 90 times the height is 1 over 120. So as a fraction, think of the 90 as 90 over 1. Top times top, 90 times 1 is 90. Bottom times bottom, 1 times 120 is 120. Well, you can reduce that. The answer is 90 over 120, but let's put it in a nicer form. You can first just cancel the zeros, 9 over 12. And at this point, I see it reduces to 3/4. 3 goes into 9 3 times, 3 goes into 12 4 times, 3/4, which I know is 0.75. So the answer to A, what's the probability is more than 30 minutes late? There's a 75% probability that Lazy Larry is more than 30 minutes late. So again, what we did is we found the area. The area is 0.75, so the probability is 0.75. And 0.75 as a percent is 75%. Now, B, what's the probability that he's less than 75 minutes late? So let me get rid of some of the work I had for A, just to reuse the same. Tried to make not too much of a mess. So less than 75 minutes late. So where's 75 minutes? 75 minutes is about here. We want less than 75. So this area of our rectangle, what's the probability of being in that area? We'll need to know our base. Well, the base goes from 0 to 75. From 0 to 75 is 75. And the height, again, is 1 over 120. So less than 75 minutes late, we find that area and that probability by doing base times height. The base, again, is 75. Times the height is 1 over 120. So you can think of the 75 as 75 over 1. Top times top, 75 times 1 is 75. Bottom times bottom, 1 times 120 is 120. And that is the answer. I can see 5 goes into them both. You could reduce it down, or you could just take a calculator and do 75 divided by 120 equals. And it should be, I think, 0.625. I better check that with my calculator, though. So let's see, 75 divided by 120 is 0.625, yeah. So if you want to write that as a percent, 0.625 is 62.5% probability. So there's 62.5% probability that Larry will be less than 75 minutes late. So C, find the probability that Larry is between 30 and 90 minutes late. So we'll start with a fresh drawing of our rectangle between 30 and 90. So from 30 to 90 is 60 minutes. 30 plus 60 is 90. So we want to basically find the area of that kind of middle section of our rectangle. So again, it's a rectangle. We're going to find the area by doing base times height. The base, again, from 30 to 90 is 60, or 60 minutes. And the height for parts A, B, and C is 1 over 120. So if you multiply base times height, think of the 60 as 60 over 1. You can do them as fractions. So you're going to multiply top times top. 60 times 1 is 60. Bottom times bottom. 1 times 120 is 120. And I can see that reduces to 1/2 right away. You can make it 6 over 12 first by canceling the zeros. I can see the top is half of the bottom. So it is 0.5, which is 50%. It's a 50% probability that Larry will be between 30 and 90 minutes late.